Number 72, sketch the graph of the rational function. Well, the very first thing we're going to do is find the vertical asymptotes. We'll get that by setting the denominator equal to 0. And we don't care about the 2x right now. We're going to say x plus 1 times x plus 2 equals 0. Then we'll split this up. We'll say x plus 1 is 0 or x plus 2 is 0. In this case, x is going to be minus 1 or x is going to be minus 2. So these are my two vertical asymptotes. All right. Now, if you were to multiply these out on the bottom, you have x squared plus 3x plus 2. To find the horizontal asymptote, divide by the largest power of x. That's why I multiplied these out, so I know to divide by x squared. Okay? So when you divide everything by x squared, you'll have 2x over x squared. You have x squared over x squared. You have 3x over x squared. You have 2 over x squared. Everything's divided by x squared. Well, on the top, one of the x's cancels. You'll have 2 over x. On the bottom, you have x squared over x squared is 1. You'll have 3x over x here and 2 over x squared here. Now we're going to let x become very large. That means this is going to turn this into a 0, and this into a 0, and this into a 0. So you end up with 0 on the top. Because x is such a large number that you take 2 divided by a very large number, it approaches 0. See? So we end up with 0 over 1 plus 0 plus 0. All right? So that's going to be 0 over 1, which is 0. So that's my horizontal asymptote when y equals 0. All right? Horizontal asymptote. Now we just need to plot some points here. We know my vertical asymptotes. We know my horizontal asymptote. Let's get some other points. F of a negative 1.5, that's in between these two numbers here. Okay. You have 2 times negative 1.5. You have negative 1.5 plus 1 and negative 1.5 plus 2. So at the top you have 2 times negative 1.5 is negative 3. On the bottom you have negative 1.5 plus 1 is negative 0.5. On the bottom over here you have negative 1.5 plus 2 is going to be a plus 0.5. So you're going to have 3 over 0.25, okay, which is going to be a plus 12. So we've got the point negative 1.5, 12. That's 1 point. All right, let's plug in a 0 in here. 2 times 0 is 0. And 0 plus 1 is 1. 0 plus 2 is 2. So we're going to have 0 on the top. 0 plus 1 is 1. 0 plus 2 is 2. See, 0, 0 is 1 point it crosses through. So even if 0 is a horizontal asymptote, still the graph passes through at 1 point, passes through the point 0, 0. And you can do that sometimes. It seems strange, because one of the definitions of asymptotes is it approaches it but never equals it. But in this case, it's going to cross through 0, 0. We'll see that in a minute. F of 2, we're going to have 2 times 2, and 2 plus 1, and 2 plus 2. So you're going to get a 4 on the top. You're going to get a 3 here and a 4. It's going to be 4 over 3 times 4 is 12, which is 1/3, which is 0.333333. So I'm going to say f of 2 is 0.3, about equal to 0.3. Well, I got some points here, and I got some asymptotes. Let's start graphing it. What do you think? Oh, I'm going to do one more point. F of minus 3, you're going to have 2 times minus 3 is a minus 6. You're going to have minus 3 plus 1 is a minus 2. And minus 3 plus 2 is a minus 1. You're going to get negative 6 over a plus 2 is going to be a minus 3. So we got the point negative 3, 3. So we're going to write down those points, and we're going to start graphing them. Let's put a vertical asymptote at negative 1, 0. Another one at negative 2. Okay. So you got a vertical asymptote here and here. All right. You got a horizontal asymptote going right through this axis right here. All right. Now let's plot some points. Negative 1.5 and 12. You're going over here to 1. There's 2. Halfway in between that is negative 1.5. You're going all the way up to 12. 2, 4, 6, 8, 10, 12. So there's 1 point. plot another point, 0, 0, right here at the origin. Going to plot another point at 2 to the right and point 3. Okay. Now, since it can't cross the axis, okay, and it's gonna go up like this. All right, it's gonna go up like that. Then you got a curve over here going through these points. It's going to approach that asymptote right there, and it's going to approach the x equals 0 asymptote. It's actually going to cross it here. It's going to come up above it. It's going to come back down and approach it on that side. Now, one more point. We're going to plot a point -3, 3. That tells me we're down here, and we're going to approach this asymptote, and we're going to approach this asymptote. So there is the graph of the function.